Hi student. Today's class we are going to discuss about challenges in federating edge resources. So what is federating? So we can decentralize the edge resources. Normally in a cloud server, the edge resources were available in the centralized cloud center. So due to that centralization, we met so many problems like bandwidth, latency, security. We met so many problems. To avoid that, the centralized resources are decentralized to the available to the edge devices. Nowadays, the current edge computing, uh, the nature is ad hoc in nature, and it is a private one, and it is the communication is irregular in manner. So it will limit the global utility. So it is not publicly available. It is unevenly geographically distributed to the nearby servers. So actually, what is our need? We need a global edge fabric. The meaning of the global edge fabric, the vision of global edge-based fabric is which federates edge resources. It means decentralized edge resources across multiple regions, faces technical, social, and legal and geopolitical challenges. So these challenges require a dynamic networking environment, so compatible with the federated edge computing scenarios. So in this video, we are going to discuss about while federating the edge resources, what are the challenges we have to meet during that installation. The first challenges is networking challenges, then management challenge, then resource challenge and modeling challenge. These are the challenges we have to meet during the implementation of, that is decentralizing the resources available in the cloud center. So in this video, especially discuss about the challenges faced, the networking challenges and solution mechanism to for the networking challenge. First one, what are the network? Actually, so many challenges were there. In this video, I have concentrated only 3 challenges. The first one is service-centric model challenge. Normally, in a traditional network model is host-centric model. It focused on only server location. It is restrictive for global edge deployment. But we need a service-centric model, not a cost-centric model. In a service-centric model, the services are identified, unique identifier, and it can replicate it and coordinate across the regions. So without requiring any knowledges of the geographic region. Hence, this due to the current design of the internet and the protocol stack, we are not able to implement the service-centric model. This is the first challenge we have to meet during the networking of the federated edge environment. Next one is the reliability and service mobility. Normally, edge environments are prone to the unreliability because of the dynamic connection and disconnection of user devices and edge nodes. Actually, to provide a continuous service delivery, we need a mechanism like service replication or service migration. It's like a plug and play functionality. We can, whenever we require the services, we can connect with them, we get the services. That is called plug and play functionality. So due to this challenge, there is quality of services reduced in this networking environment. So first challenge we discussed, service-centric model. Second one is reliability and service mobility. We are not able to achieve the reliable communication because of the dynamic connection over the user devices and the edge nodes. And also we require a continuous services. So that services provided by service replication or service migration, that is not available in the traditional networking model. Next challenge is multiple administrative domain. Actually, the federated edge environment involve multiple administrative domain, so which contain heterogeneous network infrastructure. That network must track the status of the edge servers and services. So it find the among the so many servers, it find the feasible edge node for service execution and routing. Then here two kind of scenarios were discussed. The server is nearer to the end user. Whenever the user need any services, there is a server, it is nearer to the end user. And one more thing, the server is in the another geographic region. Suppose a server needs a request, that time the server is available in the another geographic region. These two things were considered here. What is multiple administrative domain? When deploying federated environment, there is heterogeneous networks were available, heterogeneous devices were available. To handle that, to assign a feasible node, we need a better administration here. So to solve these three problems, service-centric model, reliability and service mobility, multiple administrative domain, there is a solution. So that solution is called centralized distributed hybrid solution. What is the meaning of that? So a centralized structure is, we need a centralized structure for a global view of the network and synchronization across the domain. And also we need a distributed control for coordinating operation within the private domain. So to solving these network challenges, we need a centralized distributed hybrid solution. This solution is provided by software defined networking. So this network will address the networking challenge in a federated edge environment. So what is the core concept under the software defined network? So here they separate the control plan and the data plan separately. It means that what is control plan? It deal with the network logic, and data plane deals with the packet forwarding among that network. Okay. So that enabling centralized management as well as it to provide the efficient resource utilization. First thing, so dynamic decision making. So SDN provide dynamic decision making. How? The SDN controller monitor network status in a real time, allowing a instantaneous decision making in a dynamic environment. It also has an open flow protocol. What is open flow protocol? It has southbound interface. It is called open flow. It facilitates communication between the controller and the network nodes. And one more interfaces were the north form. It allows applications to define network behavior. This is called open flow protocol. So the core concept is separate the control plane and data plane. And SDN supports dynamic decision making. It provide open flow protocol. Then it logically, already we said, it separate the control plane and data plane. So logically centralized control plane. We are talking about first control plane. What is logically centralized control plane? That logically centralized control plane simplifies the management. That centralized control plane provide a resource management for a user mobility and plug and play functionality. And also it discover the topology, that is using the protocol like open flow discovery protocol. It control the controller updates network topology in the real time, and also it accommodating the new devices and computational resources or switches. And also it supports application layer handover. It means that continuous service uploading and handover during user mobility. So these facilities provided by logically centralized control plane. Next, distributed control plane for federated edges. Under this, what are the facilities we are getting? Global scalability, hierarchical versus flat structures, and inter-domain communication. What is global scalability? So the federated edge environment require a distributed control plane to handle multiple administrative domains and to ensure global synchronization. So for that, it provide a global scalability. And hierarchical versus flat structure. What is hierarchical structure? A master controller synchronizes lower level controller. It is responsible for individual domains. The next, it provide a flat structure that controller communicate directly via the east-west interfaces to achieve synchronization. Next one is inter-domain communication. The controller coordinate, STN controller coordinate across domain to forward traffic, maintain reliability, and update service locations. Next facility provided by STN is service-centric model. It supports service tracking, load balancing. What is service tracking? STN controllers track service location and replicate services across regions. Actually, the northbound application maps services identified to the location and enabling continuous service offloading. Next is support load balancing. It determines the most feasible server for service execution, even across multiple domains, ensuring optimal performance and quality of service. Next facility provided by STN is service mobility and replication. So it supports dynamic service management and flow rules. What is dynamic service management? STN supports service creation, migration, and replication to handle varying traffic patterns and load balancing. Under flow rules, STN uses to determine optimal paths for service migration, preventing congestion and maintaining performance. Next one, the STN handle heterogeneity. It provides interoperability. The STN manages heterogeneous network types and traffic patterns, providing an interoperable environment across multiple domains and providers. So here it provides vendor independence. STN eliminates vendor dependency and compatibility issues between networking devices. What are the practical applications of STN? The campus environment and edge computing environment were the practical applications. I'll summarize here. This video, we discussed about the challenges faced during the implementation of decentralizing the edge resources, that is federating the edge resources. So it faces networking challenge, management challenge, resource challenge, modeling challenge. Among these challenges, we especially concentrating on networking challenge. So under networking challenge, we discussed three challenges: service-centric model, reliability, and service mobility, multiple administrative domain. These challenges were addressed by centralized distributed model. So that model is provided by software-defined network. That network, the main concept of that network is separate the control plane and data plane and provide the services and also addresses these challenges. Thank you guys. I refer these concepts from this reference. Thank you all.